This is going to be a quick overview of quadratic functions. A quadratic equation is a second-degree polynomial. This word degree means the highest power. So a quadratic function has the highest power is 2. The name of the graph of a quadratic function is a parabola. The parabolas that we're going to be talking about right now are going to either open up or they're going to open down. The standard form equation of a quadratic function is y equals ax squared plus bx plus c. The ax squared term is what's called the quadratic term. That's because it's the one that has the x squared attached to it. Bx is what we call the linear term, and c is the constant. The quadratic term makes this a quadratic function. Again, the highest power is 2, and therefore is going to be responsible as to whether the parabola is going to open up or open down. When the value of a is positive, then my parabola is going to open up. When the value of a is negative, then my parabola is going to open down. Let's talk a little bit about the graph. Notice that this graph is symmetrical. I can cut it down here in half. When I cut it in half, that is called the axis of symmetry. The axis of symmetry passes through the vertex. The vertex of the parabola is the turning point of the parabola. The vertex is really important. It's by far one of the most important parts of the graph that you want to make sure that you plot, because it is the turning point. Notice how this graph right now is decreasing and then it picks up and increases. And where that change happens of decreasing, increasing is going to occur at the vertex. So the equation for the axis of symmetry is x equals negative b over 2a. It's right here in your notes on your screen. The a and the b come from the equation y equals ax squared plus bx plus c. Because the axis of symmetry passes through the vertex, then the vertex is going to have the same exact x value. So the vertex is going to be negative b over 2a. You have to realize that negative b over 2a is going to give me a number. It could be positive 4, negative 2, 1/2. And then we're going to say f of negative b over 2a. Whenever you write f of something, that just basically means take that value and substitute it, okay? Plug it in, basically. All right, so this is kind of like the basic parts of a quadratic function. Let's take a look at an example. For the quadratic function y equals x squared minus 2x minus 3, determine whether the parabola opens up or down. This one right now is pretty simple. Remember what we said. The standard form equation of a parabola is y equals ax squared plus bx plus c. And I told you the value of a is going to determine whether or not the parabola opens up or down. Right now we have the equation y equals x squared minus 2x minus 3. When I don't have a coefficient or a number in front of the x squared right now, that's because that number is a 1 and it is a positive 1. Therefore, this parabola is going to open up. The axis of symmetry is going to be the equation x equals negative b over 2a. One of the things that I want to warn you that drives me absolutely crazy when my own students do it, you don't want to write axis of symmetry equals and then the number. That is because the axis of symmetry is a line. In this case, it's going to be a vertical line. And the equation of that vertical line has to be x equals some number. So don't write it like that. Instead, we can write it the way you see it here. The axis of symmetry is x equals negative b over 2a. And now we're going to substitute those values from the equation. So back to the equation, a equals 1, b equals negative 2, c equals negative 3. So x equals negative, b happens to be negative 2 over 2 times a, which is 1. Negative negative is a positive 2 over 2. Therefore, x equals 1 is the equation of the axis of symmetry. And like we said before, the vertex is going to have exactly the same x value as the axis of symmetry. So the vertex is going to be 1 comma something. This something we're going to figure out by substituting x equals 1 into the equation wherever you see an x. So if the equation says y equals x squared, which again, we're going to substitute the x is equal to 1, minus 2 times x, we're substituting for 1, minus 3, okay, so I've rewritten the equation, but I replaced every x with the number 1, then I can solve. 1 squared is 1, minus 2 times 1 is 2, minus 3, 1 minus 2 is negative, 1 minus 3 is negative 4. Therefore, the vertex for this problem is going to be the point 1 comma negative 4. So the axis of symmetry equation, we said x is equal to 1. The vertex we said is the point 1 comma negative 4. And then now our job is to figure out the x-intercepts. Let's talk about x-intercepts for a second. I'm going to draw on the screen 3 coordinate planes. There are only 3 things that are going to happen when you have a parabola. The parabola could completely miss the x-axis and never touch it. The parabola can touch the x-axis at exactly 1 point. Or the parabola crosses the x-axis at 2 points. Those places where it crosses the x-axis, those are what we call our solutions. Another word for solutions, when we're talking about parabolas, are your x-intercepts or your zeros, or sometimes they're also called your roots. So in this particular case, when they're asking me for my x-intercepts, they're trying to figure out what are the solutions to this problem. So to figure out the x-intercept, remember, we have to set y equal to 0. I'm going to take my equation, x squared minus 2x minus 3, and I'm going to set it equal to 0. In order to solve this, I have a few options. Option number 1, I could try to factor. Option number 2, I can use the quadratic formula. And for those of you who need a review of the quadratic formula, there's another video that I'm going to link in the description below that you can follow along to remember how to use the quadratic formula. I also have videos on factoring, so you can also practice that as well. So in this case, let's go ahead and try to factor. It has to multiply to give me negative 3, and it has to add to equal negative 2. So what's going to multiply to give me negative 3? That's going to add to give me negative 2. It's going to be x minus 3 times x plus 1. And then I write down equals 0. So negative 3 times 1 is negative 3. Negative 3x and then plus 1x is going to give me negative 2x. By the zero product property, I take each factor and I set it equal to 0 and solve. From here, if I add 3 to both sides, I get x equals 3. And then if x plus 1 equals 0, then x is equal to negative 1. So there go my 2 x-intercepts. So we have the point 3 comma 0 and the point negative 1 comma 0. So now I can take all of this information and put it on the graph. Remember, this is my x-axis, this is my y-axis. I know that the parabola is going to open up. I also know the equation for the axis of symmetry, and I know the vertex is the point 1 comma negative 4. So I'm going to go ahead and start with the vertex, and I'm going to plot 1 comma negative 4. So here's the vertex. Then my zeros, my x-intercepts, are at x is equal to 3 and x is equal to negative 1. I know this parabola is going to open up, so I'm going to go ahead and carefully draw my parabola. So by putting all of these points together on the graph, I have a good picture of what this parabola is going to look like. Sometimes when you don't have such nice points, for example, you have a vertex that is the same possibly as the x-intercept and you don't have more points to go by, then one of the things that you can do is create a t-chart where you simply substitute values for x and y, and then that is going to give you an answer, okay? So at this point right now, we don't have to do that because this one actually graphs quite nicely by just having the x-intercepts. Notice that we have a parabola that opens up. Also notice that in this particular case, there are two roots. There are two x-intercepts, +3 and -1. Also, we have the equation of the axis of symmetry that when they ask you to graph a parabola, you don't necessarily have to graph it, but just for the sake of you understanding that this parabola is symmetrical, notice the distance from the axis of symmetry to the 3 is 2 spaces, and to the -1 is 2 spaces. So it's definitely centered, and it's equidistant from the axis of symmetry. I hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.